In this video, we're going to try to sort our way through this review 2, problem number 3, part B. So in this problem, we are trying to find a vector equation for a line that contains the point 2, negative 5, 3, which is somewhere off of our line L. And our equation for line L is negative 4, 1, 2 plus t times 1, negative 2, 3. So this is tricky because we want our line to be perpendicular. We want this to be, starting from P, we want to go perpendicular to our line L, but we can't just, there are an infinite number of lines that are perpendicular to this line L in space through that point Q, but through this point P that's not on the line, there's going to be only one line that's going to be parallel, that's going to be perpendicular rather to that line L. So to sort this out, we're going to call this point X right here that we don't know. And so what we want is for this PX, so this vector PX that we're creating with this unknown point X to be perpendicular to line L. And we also know that because it's perpendicular, that means that px, this unknown vector, when we dot it with the direction vector for line L, which is 1, negative 2, 3, 1, negative 2, 3, that's going to have to be 0. Okay. Now, we do know from this picture that if we look at this vector PQ, and then we take some multiple of our direction vector along this line, so this vector right here is going to be some multiple of our direction vector, so that's going to be t times that 1, negative 2, 3, for some choice of t that we don't know yet. So we can say then, looking at that the PQ plus that t times 1, negative 2, 3 is going to be equal to our vector PX. Okay. Now we're going to then take our vector px, we're coming back to this now, and we want that dot product to be 0. So that means our px, let's see, well, we can figure out what pq is too. Let's do that. Pq is going to be tip minus tail, so that's negative 4 minus 2 is negative 6, and 1 minus 5 is negative 4, and 2 minus negative 3 is 5. So there's our vector PQ. And did I do that right? 2 minus negative 3, I think I did. Oh no, I see that I wrote down P incorrectly, so let me fix that now. I didn't think that if I can fix that there. I got the negative in the wrong place. So let me go back to green. And so let's make this what it should be. That should be 2, and it should be negative 5, positive 3. I knew that vector didn't sound right. And so that means that our vector PQ is going to be instead, let's see, so Q is going to be, it's going to be negative 4, minus 2 is negative 6, and the 1 minus negative 5 is positive 6, and the 2 minus 3 is negative 1. And that looks right. So there's our PQ. And so our PX, we're going to say is going to be this negative 6, 6, negative 1. That's our PQ, plus t times this 1, negative 2, 3. And we don't know what the t is yet. So there's our vector PQ, and we're going to use that in our dot product equation with 1, negative 2, 3, and see that that must be equal to 0. So we're going to take the negative 6, 6, negative 1, plus the t times 1, negative 2, 3. I'm going to take that quantity and dot it with the 1, negative 2, 3, and say that that must be 0. So that's going to be, we're going to get, I'm going to distribute this over here so we can take that dot product times each of those. So the first one, the negative 6 times 1 is negative 6. The 6 times negative 2 is negative 12. And the negative 1 times 3 is a minus 3. And then we're going to get this is going to be t times 1 will be t. And the negative 2t times the negative 2 is going to be a plus 4t. And the t times 3 is 3t, times that 3 is going to be 9t, and that's going to be equal to 0. So let's see, we have 9t plus t is 10t plus 4t is 14t. And we're going to get negative 18, so that's negative 21. We're going to add that to the other side to make it 21. So we're going to get t is 21/14, or 3/2. Okay, we're making real progress now towards understanding what this px is going to be. So now our px is going to be this negative 6, 6, negative 1, plus, and we're going to get 3/2 times 1, negative 2, 3. And so let's see, 3/2 plus the negative 12/2 is going to be 9/2. The negative 6/2, which is negative 3, plus 6 is going to be 3. And the 9/2 minus 2/2 will be 7/2. So this is our vector px. And that, remember, is going to be our direction vector for our line through P perpendicular to line L. Now, any multiple of this vector is still pointing in the same direction, so it might be nice just to multiply through by 2 and make this just a little nicer. So I'll just call that, I think I called it W on the review answer key. So if we multiply that by 2, it's still going to serve us well as a direction vector for our line perpendicular to line L. And it'll just be a little nicer and cleaner. So that'll be 9, 6, 7. So then getting to our line, so our line that is through point P perpendicular to our line L is going to be x, y, z is going to be our starting point P, which is 2, negative 5, 3, plus any multiple t times our direction vector, which was our px, which is 9, 6, 7, or any multiple of that. Crazy.